Biochemistry and Cell Organisation Taskbook, video, Markscheme and commentary. Question 6, bit of a crazy question this. It's only for 6 marks, but really tough. We have an inverted funnel containing a mixture of sugars, so all of these sugar concentrations are in there, in A. And it's in a beaker containing solution B, which has all of these other sugars in it at these concentrations. And these are just molar concentrations, mole per dm cubed. And we've got glass there, but this S is our selectively or partially permeable membrane. So some stuff can get through this membrane, some stuff can't. And it tells us what can and can't. The membrane is permeable to monosaccharides and water, but not to disaccharides. So immediately we can go, well, we've got water in solution B, we've got water in solution A, we've got monosaccharides, fructose and glucose, not maltose. Check your answers, folks. We have got a disaccharide sucrose, because that's glucose and fructose. That's our disaccharide there. And maltose here, that's our disaccharide. It's two glucoses. Okay. Which of the solutions would have the higher, less negative water potential? So what's the highest water potential? The highest water potential is water. And what's the lowest water potential? Or water with lots and lots of stuff dissolved in it. So we're looking for the least concentrated solution from A or B. So least concentrated solution. So looking at the numbers there, pretty tricky because they're not all to the same level of precision. But if we look down solution A and add up the second decimal place, we've got 5, 6, 7, 8, so 0.085. And in solution B, 0.3 there, so sucrose, 0.3, much higher than all of that put together. So solution B is more concentrated, so solution A is less concentrated, so higher water potential, so A. So A is more like water than B. B's got more stuff dissolved in it. And we just need to put that into a sensible sentence. So the concentration of solutes which are our sugars is lower in A. We don't need to put any numbers there. Part B. After a time interval, would the level of the liquid in the stem have risen, stayed in the same place, or fallen? Underline your choice and explain your reason. So this line here, does it go up, does it go down, or does it stay the same? To decide what's going on here, so we've got higher water potential, so higher water potential and lower water potential there. So the start of the question has pointed us in the direction of asking us which is the highest water potential. And then if you remember your osmosis definition, it's the movement of water through a selectively permeable membrane from high to low water potential. So water is going to move there from high to low water potential, and so our level there is actually going to go down. So fallen because our water moves, and I'm not always going to say by osmosis, from high water potential to low water potential. Name a solution that would diffuse into A and out of A. Right. So, into A, we're looking at, can we find a concentration difference between anything in A and B that would make it move? And also, can it get through this selectively permeable membrane? Remember, the membrane is permeable to monosaccharides, but not disaccharides. So it's not going to be sucrose that moves, or maltose that moves. Could be glucose or fructose. And what would glucose do? Well, it's at a higher concentration in A than it is in B. So glucose would actually go from A to B, and if we look at fructose, 0.06 is higher than 0.02, so fructose would go from B to A. So into A, fructose, out of A, that's our glucose. If you got all 6 there, you're brilliant, well done.